Okay, let's have a look at challenge number 51. This time we're going to have a spatial challenge, which I always find quite interesting. That's something Arch is pretty good. And what we have two input data set. One is a list of store number, so we have 10 of the stores. CO, I guess Colorado. Then the second data set is some kind of spatial file. We have some kind of counties within the state. So the M, we're looking for two parts. We're looking for Let me just say. So we're looking for each store, we're looking for a 15-mile radius. Then within those 15-mile radius, we're looking for one is overlap regarding to the county. So the first data set, you can see for one store, you have overlap with 5 counties. You're looking for how big each county is, how much overlap, and the percentage of it. The second one we're looking probably is the overall percentage for the overlapping. So at county level, how much overlaps with the store. So you're looking from two perspectives, one from a store perspective, the other from the county perspective. So the first thing is, since we're looking for the county number, let's actually do the county polygon first. That's probably the quicker part. What we have spatial information. That's the easiest way to find all the information you need, length, area, etc. So we're looking for probably square miles on the object. That should give the polygon for each county. And we'll get a miles number. So let's just check Adams County. So 1,183. Yeah, that's probably the number. So that's probably looking right. The stores. The store we have a lat long, so we need to create points. More points. Because what we're looking for is 15 miles radius. So that's basically indicates it's a trade area. Create points first. Next, we can just drag a trade area after the points. So from the centroid, the measure we're looking for is 15 units is miles. That will create the boundary for each store. Polygon shape. We're looking for the overall match. So that means we're looking for spatial match. So we're looking for some intersection. You try to for each store, the 15-mile trade area, how many county it can capture basically. So moving, let's slam things up. So the first one, remember to change the spatial file. We have a multiple files at the moment. So we're looking for the trade area. Then correspondingly, we're looking the spatial object. We're looking for intersection. That should be fun. Let's just run it. We'll get 63 rows. Is that so far? That's good because on top you have 63. So we'll probably capture all the correct matches. So you have 5 at the store. 1, 2, 3, 4, 5. So yeah, you have 10 rows for 0 and 1. So they're probably doing a good job. And that's done. We're looking for the overlapping areas. So we're looking for the intersection for our trade area with the corresponding spatial area. So we're looking for intersection. That's a spatial process. Trade area. Second spatial is the spatial objects. We're looking for create section. So you can see on the picture, we're looking for the middle part when the overlap. You can delete some columns if you need. For us, that should be okay for the moment. So the last one, the column, the spatial process, that should be the polygon. And we can once again repeat the process, spatial information. Let's find how much of the overlapping area is. Mouse, that's fun. The our stuff. Oop, not correctly. Not the centroid. Spatial process I need. Good. Okay, so let's see. So the first one, actually, let me clear things up a bit, make it easier to keep track. Store ID we want, address we don't care address, lat long, all those things fine. Trade area we need for downstream process, radius size we don't care, county name, probably keep track of that. Key we don't care, spatial objects, that's the counting. So on the mouse, we need to select. Oop. So let me probably move the screen a bit smaller. So those are the selection fields for me. Other columns were not necessarily needed for the downstream workflow. Intersections fine. Let's look at the results again. We'll probably have less columns, so it's easier to understand. Yeah. So each spatial object, we have some kind of corresponding numbers after it. To calculate the percentage formula. At the moment, you can see it's red arrow on the corner, triangle, indicates it's already a number, so it's running errors. What do they say? They call it percent overlap. Mhm. So how much percent? That's the area of the second area divided by the area of the first one. We're looking for double. So you're looking for percentage. So probably times 10 in the end. That should give you the answer for number one. Store one. Let's see. Probably those two. So 13.6, 12.5. Nope. So it was 12.5. So you have ID, county, number. ID, county. Let's do a join to check. Mm-hmm. So we'll try to join on store ID. We'll try and join on the county name. We don't need everything else. County. So the answer should be 1, 2, 3. For us, we're looking for schema 1, 2, 3 overlap. Mm-hmm. So mouse 13.6, 12.99. Yeah, so it's just up to the rounding to decimals. Otherwise, it's looks all good. So that's done for the first part. The second part, we're still doing the same thing. We were looking for the county level. So for each county, how big is the county itself, how much how much area of the county has overlap with store. Since we don't care any particular store, let's actually look at this part. So from the trade area, let's group all those trade areas. So summarize is a very good one to actually aggregate everything together. Remember, summarize is not just for strings, numbers. Actually can apply to spatial objects. So if we go spatial, we can actually combine housing. Nah, we don't need to change the name. Let's keep it as I think the next one, I'll probably just do append. So you have the orders. Let me put a browser on it so we can see. So the intention is for each of the trade county, you have a polygon. We're going to just slap the entire trade area on top of it. We just need, because we can do the reverse of things. So this is the overall grouping. So each store, you have a location. They have some kind of circles. Probably this is a circle, this is a circle, etc. Collectively, they form a single overlapping areas. Then we look in the whole area overlapping with individual county polygons. almost identical as above. We're still gonna apply a spatial process. We're looking for the intersection. So we'll do intersection the overlapping county area coordinate freely. So that should output the overlapping for each county level. Then we'll do a formula. We can just probably copy paste. So you still call the spatial process error will probably still get the same thing. The other column name probably still preserve as it is. So this case we can see some of the county has no overlapping, so it's probably outside. That's fine because we're supposed to have 11 of the rows. So let's filter out. Spatial process overlap is not now. Oh, sorry, it's overlapping on field. So for add the two A's, you have a 22, 39. 22, 39 if on the 100%. And okay. So I have no idea about Colorado. I guess this Bloomfield is a city center. That's why it probably have overlap with everything. And that is how we can actually use a spatial process to do analysis. It's very powerful with an Alteryx, and you can see with a few tools on top, we can actually do a lot of spatial matching, joining, intersection. It's much easier than other tools to play with, and you can visualize in the browse for the final results as well. Okay, thanks for watching.